Okay, so I just want to say I gave you this question where the equation is y equals, say, ax plus 2 over x. Let's go plus b. Okay, so I just gave you that equation. Can you tell me what a and b are? Just by looking at that equation. Okay, now here's the other question I could pose. If I gave you, or what information could you give me that I could find out a? What information could you give me that I could find out a without just saying a is 5? Okay, what is the way a test could ask you? Find a and b, the sum put in the blank. Right, it's a numerical response question. Okay, that's what we're going to be dealing with a bit today. Now, in this question, this specific question, do you see that A would be your horizontal asymptote? Do you see that? If I gave you the horizontal asymptote of 2, say I say the horizontal do you see that A would have to be 2? Does that make sense? Because how do we find out asymptotes? If they're the same, we cross them out and whatever number is left. So then I would go, oh, okay, that's A. Now, if I gave you the vertical asymptote is 3, what must B be? Negative 3. So therefore, B equals negative 3. Okay? Now again, good luck getting that question if you have no idea how to find horizontal asymptotes. Okay? But that's what we're going to do today. They're going to give you as minimal information as possible, and you've got to actually work backwards now and think, well, they're not asking me for those anymore. They're giving me those, and I have to find an equation. Okay? But remember, vertical asymptotes are always the thing that made the bottom equal 0. So now we know that B would have to be negative 3, or else the asymptote wouldn't be 3. Okay? So we're going to be solving radical equations. If you look back, radical and rational, we haven't been doing equations. Now they equal something. Okay? We haven't been doing stuff that equaled anything up to now in this unit. But we're going to today. Now, what's still, let's go right back to the very first lesson. A radical equation is any equation that contains a radical. Now, that's not exactly right. The radical, or the variable, would be under the radical sign. Because I wouldn't say that x plus square root 25 is a radical equation. That's just x plus 5. Okay? And a rational equation is one where the x is in the denominator. Okay? That is the easiest, two easiest examples that I could give you that say those are radical and rational. Okay? And why are they rocks in our shoe? Because these ones have non-permissibles, right? Addition, like addition and multiplication, they're the nice guys, right? They're low maintenance. Don't worry I don't need any help, okay? But not these guys. Are like, no, no, you just can't. You got to find out what I'm allowed and what I'm not allowed and the whole thing, right? Now, you need to know over and over and over again that these are the same things, right? They're actually the answers to all of our equations. And don't get them mixed up with factors. They are opposite the factors. Okay? If the zeros were 2 and 5, and this was a quadratic, then that would be, x minus 2, x minus 5, 0. These are factors. Right? They are not the same thing as zeros, roots, and x-intercepts. Again, if I asked you this a year from now, many of you wouldn't be able to tell me this. Okay? So that's why you need it on a study sheet somewhere where you can read it, it's highlighted, make sure you know this. Because remember, you have this game you have to play on that day that you've got to get half your mark done, right? So you've got to come in with all that short-term stuff in your head to be able to do the test, and then it's just you get to let it go. Now, let's start off with a really, really simple equation. Now, here is a little ball on a pendulum, okay? And it is swinging back, or forth, and back, okay? Now, the longer a string is on a pendulum, the longer it takes the ball to go up and then back again, okay? If it's really little, it just goes back and forth really quick, okay? So the longer the string, the longer the time it takes for one period, we call that, there and back, okay? So some smart little physicist came up with, hey, time equals 0.2 square root the length of the string. So, and you can see why this is quite valuable actually, because if you've ever seen a grandfather clock, if that pendulum, if you just stretch it a little bit, it won't keep time anymore. Well, it will keep time, but it won't keep the right time, right? So that pendulum is at the exact, so it actually does it in 2 seconds. 1, 2. You can hear it always go click, 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 okay? So its period would be 2 seconds. Now, if they asked, well, how long would it take? Or how long would the string be if it takes 1 second to go back and forth? Well, then I'm got this now. 1 equals 0.2 root L. Okay? There are 3 ways to solve this. Let's get them all. What's the way I can solve this? Okay. How would I bring the 0.2 over? Okay, I would divide 0.2. Okay, so let's do it this way. The first way, I would 1 equals 0.2 root L. Okay, and then I would divide by 0.2, and I would get 5 equals square root L. Then I would square both sides, and I will get 25 equals L. That's one way. It's another way. Okay, you don't want to do just one way on a diploma. You got to think of 2 other ways to do this one. That's actually going to be how you're going to do well, is if you actually know 3 ways to do every question. Come on, what's another way? How would you prove this? How would you know this for sure? Come on, 50% of your mark, guys. Every single question you can do 3 times is going to be money in the bank, right? what's another way? You just, oh, you did one way. What's that little thing with buttons on your desk? How can I use that? Okay, graph it. Now, how would you graph it? Yep. But, so what am I going to put in my calculator? Well, so you go y1 equals 1, y2 equals square root x. And you'll go x equal, it's right there. Okay? So, and you'll get x equal 25. What is another way I could put this into my calculator? Yep. Yeah, I can subtract the 1, right? So here's another, so we're going to write calc on here. So this would be 1 equals 0.2 root L minus 1 minus 1. 0 equals 0.2 root L minus 1. And then I would go y1 would equal 0.2 L minus 1, and y2 I would make equal 0. And again, I would find, that would be an x, right? I guess if I was to graph it. And then I will find x equals 25. Okay? So that's 3 ways to do that question. Okay, and sometimes they can be confusing when it's asking you to do one way. You're thinking, I don't even know how I would do that algebraically. Okay, here is a function. It's y equals f of x. Now, you have to be prepared on your exam, on your diploma, that most questions will be y equals f of x. Because y equals f of x, your calculator will not save you. You have no idea what this thing is. Right? So you've actually got to use all of your knowledge of those little things, right? That, all of your transformations. Now, what would be the 0 of this function? -2. What would be the root of this equation? X equals -2. When does f of x equal 3? Seven? Yeah, I'm liking that. The root of f of x minus 4 equals 0. So what is x? Okay? Now there's 2 ways to do it. Take f of x and do what with it? What is this doing to the graph? It's moving it 4 down. If I took this graph and moved it 4 down, where will it go through 0? In other words, where is it 4 up right now? Because when I move it 4 down, it will be going through 0, right? 14. See, right here, if I take that graph and move it down 4, this will equal 14. Okay, now the other way that was said, well, why don't I just add 4 to both sides? When does f of x equal 4? 14. It is important you understand both ways, though, because the diploma wants to know, could you do it both ways? Do you understand that? Okay? And it's obviously my job to make sure you do. Huge. Okay. No, because that is really f of x equals 4. Well, how about I do this? Actually, I like that. I'm going to yeah. Basically, see, this is actually really our y value. This is the function, right? So then you add 4, right? Okay. Now, how am I going to deal with this one? F of x plus 6 equals 0. Okay, so I'm going to take this thing and move it 6 left. So when is it going through right now? At negative 2. If I take this entire graph and I move it, so we're going to move left. Why don't I actually use, we're going to do a horizontal translation. 6 units left, right? So it is, so negative 2 goes to negative 8. Okay? Now, this is a good one, right? When does f of x minus 3 equal 5? Okay, now that messes with you a bit, right? So what I would ask is, when does f of x equal 5? So when does f of x equal 5? 23? Yep. So when x equals 23. So when would x minus 3? So we're either thinking 20 or 26 here, right? I could probably split the class in half right now. Is it 20 or 26? I have to go 3 to the right. Right? This is a horizontal translation, 3 units, right? Why? Because x is getting replaced with x minus 3. Now, it depends how you know your transformation unit, because some people, that's like back to the comfort stuff again. Okay, yeah, that's good. And some people, it's like, oh man, I still don't know that stuff. And it's haunting me again. And we're going to do trig, and there's lots of it in trig. Okay? So, hey, if you're not getting it, maybe it's going to start clicking. But I am quite confident most of you guys are understanding this. So this would be 26. Okay? Okay. Remember this stuff? I heard an I don't. Okay? This is f of g of x minus 5 equals 0. Determined graphically to the nearest hundredth. Okay, so this is a good numerical response type question. How would I solve A? You just got to get through these 3. Help me out here. What would I do? Okay, but why can't I just put f of x? Oh, yeah. Yeah, if you forget a bracket, you will get this one wrong. You must put brackets here and here. So those simple little things, in fact, even if you put it on the other side, you'll still get that wrong without brackets. Because if you put 2x minus 3 divided by x minus 1, if you put that into your calculator, it will think this, that you want to go 2x minus 3 divided by x, and then you want to minus 1 to all that. That's what your calculator is thinking. Okay, so you always have to make sure you put brackets here and brackets here, so it knows to put it there. Okay, so again, all of you have had this calculator for 3 years. Okay, that is why we recommend it so highly in grade 10. So by grade 12, you know this stuff. Okay, you know that if you miss the brackets whenever you do substitution or whenever you're dividing. Okay, so what do you get? You want to put all of this into y1, put this into y2. Okay, everybody try it. Even those of you that are going to fake it, at least put some effort into just hitting some buttons. And then give that look of, what? That can't be right. So then I won't ask you. Even better if you actually lean to a friend and go, where'd you put it? I didn't do it, but it'll look like I'm asking you. Okay, what are we getting? 0.67, right? We have 2/3. Okay, next one. What would I put into y1? What is root f of x? That would be root 2x minus 3. Who remembers what this means? Put h of x inside g of x. Remember that? That is not multiplication. So that would be, I'm going to take h of x, and I'm going to put it right in there. Okay? So then that would be x plus 5 minus 1, which is actually x plus 4. Okay, so this is y1. This will be y2. And what do you get? Okay, you shouldn't find anything. No solution. Okay. Now, C is a good one because we have f over g of x. So that means 2x minus 3 over x minus 1 equals g of x again is x minus 1 over h of x, which is x plus 5. Now, how would we solve this algebraically? Cross multiply, right? So it would be 2x minus 3 times x plus 5 equals x minus 1 times x minus 1. Now, are these two the same? Okay, so if you just opened your book and it's had a question like 6 here and gave you this, and question 7 gave you this, would you be like, hey, those are the same questions? What's the difference between this and this? This one has no non-permissibles. This one has 2 of them. So don't go and put this into your calculator because it will give you different answers than this. In fact, even when you algebraically solve this, what if you get x equals 1 and 7? Are you guys going to be wise enough to go, when I first did this, I'm going to go, yeah, and x cannot equal 1 or negative 5. Because when you go and solve it and you get the answers 1 and 7, there will be that multiple choice waiting for you that said x could equal 1 or 7. There is also the one that would say no, only equals 7, because 1's not permissible. Yep. Yes, you'll get the same zeros, but one of your zeros may not be, or it may be a non-permissible. Okay, so you will get the same zeros. So algebraically, that's the only way to solve it. That's the only way we know how. But stay away from turning it into that and then graphing it because of the non-permissibles. Okay, and we get two answers, right? X equals negative 10.52 and 1.52. Again, make sure that you put them in brackets. Okay. Now we're doing 1 to 9. Okay, so I'm just scrolling through the homework quick because I want to make a comment. That question 2D, in my opinion, is the best question in the homework. Okay? Really good diploma question. Most people, I would say that probably 99.999% of students that have not been showing up to class would never get D. Wouldn't have a chance. They would just be like, ugh. And it is not a hard question. But you really have to know your stuff. No, no. You gotta look, yeah. You'll know behaviors, right? And that's the thing, like you just have to know, like if you ever see anything and you see this, right? If it's ever where it becomes, you have to lift up your pencil, there was an asymptote.